Okay, this is lesson 5.1, and in this lesson we're going to interpret statistics. Um, Before we do, we want to recall a few statistics here. First, the measures of central tendency, and that's a mean, median, and mode. And the reason they're called central tendency is because all three of these are ways that we can look for the middle. The first one's the mean, and the mean is just the average, so you're adding up all the values and dividing by how many there are. The goal is to find the average, like an average mark in a class. We take all your marks, add them up, and divide by how many students. Median. Median's the middle number when you sort the data from lowest to highest. So it's the person or people that are in the middle of the pack. And the mode is just the one that occurs most often. There's one more measurement that we're familiar with. It's not a measure of central tendency, but it's the range. The range shows you how spread out the data is. So it's the highest minus the lowest. So let's look at an example and look at the measures of central tendency for the example, and we'll also find the range. So the 14 students in Jesse's math class measured their heights to the nearest centimeter. Determine the measures of central tendency and the range for this set of data. Let's start with the mode. Mode is the number that occurs the most often. And it's a little tricky to see the mode when the data is not sorted. In fact, the data has to be sorted to find the median as well. So let's sort the data from highest to lowest. And the way I like to sort data is I'm just going to take my list here and I'm going to write the lowest number underneath the first number so we can kind of line them up, and I'm going to cross them off as I go. So the lowest number in this list is 153. So I'll cross that one off. The next lowest is 157. So I'll cross that one off. And then we've got 160. So I'll cross off. Where did my 160 go? Oh, there it is. Next is 164. Cross off my 164, and then I've got 165, and then I've got 167, and there's actually another 167. Looks like we might have a mode there. Let's find out if there's anything else. 168, and next is, big jump here, 175. And then we've got 176, and then we've got 178, and then we've got 179, 180, and 182. And that's all of our numbers crossed out, and there's the numbers right underneath, so we've got the same number of numbers, so we're good to go. The mode, if we look, there's 2 167s. So that's going to be our mode. Remember, if there was another number that occurred twice, then we'd have two modes and it would be both numbers. If there was only one 167 and every number just occurred once, there would be no mode. Median. All right, let's look for our middle. To find the middle, we're going to start by covering up one number from each side until we get to a middle. So 1, 2, 3, 4, 5, 6, and we're not on a single number, we're actually between two numbers. Because if we cover them up, the numbers disappear. We need those numbers to find the middle. The middle is right here. So right there. And to figure out what that is, we have to add the two numbers, 167 and 168. And if you're doing this on a calculator, use a bracket or else you're going to get the wrong answer, and divide it by 2. Sometimes it's really easy to tell what the middle is. Well, it's just 167.5. If the numbers are a little bit more spread out, you might want to actually add them and divide by 2. Mean. The mean is where we find the total. So you add up all those numbers and we divide by, well, there's 14 students, so we divide by 14. Now, in the interest of saving a little bit of time here, I'm not going to actually add these up. I know what the answer is. It's 169.36. So if you want to practice, add it all up, divide by 14, and if you end up with 169.36, you did it right. And our last one's the range. To find the range, we're going to take the biggest number, 182, and we're going to subtract the smallest number, 153. And if we do that, we get 29. So those are the measures of central tendency. B says, what percent of the class is shorter than each measure of central tendency? All right, let's start with mode. Let's start with mean. Mean. The mean is 169.36. So the question is, what percent of the class? Well, to figure out a percent, we need to figure out how many out of 14 are less than 169.36. Well, 169.36 would be right here. So everybody under that. So that's 1, 2, 3, 4, 5, 6, 7, 8 people. So 8 people out of 14. If we divide those, we get 0.57. As a percent, that would be 57%. So how many out of 14? Well, 8 people are less than that number. If we want to do median, so it might make sense, but the median is 167.5. So how many out of 14 are less than the median? Well, the median's right in the middle. And if we count, there's 1, 2, 3, 4, 5, 6, 7 people less than the median. 7 out of 14 is 0.5, which is 50%. If you forget how to make a decimal percent, just multiply it by 100. 50% should make sense because the median's the middle. So half should be under the middle and half should be above the middle. The only way that's not true is if one of the numbers is the middle, then you get a number slightly less than half, underneath and above, because one of the numbers is the middle. Last one's mode. The mode was 167. So how many out of 14 are less than 167? Well, 167 is here, so that's 1, 2, 3, 4, 5. 5 out of 14, which is approximately 0.36, which is 36%. All right, last question. Ryan is taller than 67% of the class. How many students are shorter than he is? Well, this is actually kind of the same question that we just did, but in reverse. This time we have the answer. So we know that 65% of the class is taller than Ryan. Oh, sorry. Ryan's taller than 65% of the class. 65% as a decimal is 0.65. So we need to figure out how many people out of 14 would give us that 65%. To do that, we're just taking the 65% and multiplying by 14. And if we do that, we get 9.1. So Ryan has to be taller than 9.1 people. Well, he can't be taller than 9.1 people, but if Ryan was the 10th person, nine people would be shorter. Sorry, because 9 people would be shorter. So whatever we get from multiplying by how many people there are, we would round up, and that's the person Ryan is. So if we go look in our list and count to the 10th person, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ryan is 176 centimeters. All right, let's flip the page. So along with central tendency, there's also measures of spread. Range is actually a measure of spread, but we'll look at a couple more here. One called standard deviation shows you how closely the data is centered around the middle. And this is something we looked at in grade 11, if you took grade 11 college. Percentiles tells you what percent of the data are less than a particular value. So we would say that 65% of the data are less than or equal to the 65th percentile. So Ryan was in the 65th percentile, which means 65% of people were shorter than he was. The last one is called quartiles. Quartiles just divide the data into 4 equal parts. We know of one of them already, the second quartile. It's the median. It splits the entire data set in half. So it's the same as the 50th percentile, because if you split the data in half, 50% of people would be less than that half. On a number line, if we were looking, here's the 0 percentile. If you were that person, nobody would be less than you. And if you were the person at the top, everyone would be less than you. The second quartile is right in the middle. It's the 50th percentile. So that's the second quartile. So if you can find the middle, you've split the data in half. Now this might help to make some sense. The first quartile would split the bottom half of the data in half again. So the first quartile is the median of the lower half. It divides the lower half in half. So it's the same as the, well, what's in the middle of 0 and 50? 25. So you might be able to guess now the third quartile is the median of the upper half. And it splits the data at the 75th percentile. So let's find some quartiles. Here's the hourly rates of pay in dollars for 17 high school students with part-time jobs. This data might be a little old. Some of those numbers are pretty low. So let's organize the data first, and let's find the quartiles. Smallest to lowest, lowest to highest, smallest to biggest. We've got 7.5, 7.75, 8.0, 8.25, nope, another 8.0, 8.25, 9.0, 9.15, 9.25, 9.45, 9.5, 9.75, 10.5, 10.75, 11.25, 11.5, 12.5, and 13. All right, there we go. We got them all on there. So let's find the quartiles. Well, the middle should be the easiest one to find. That's quarter 2. We find that one first. So let's start from the ends and cover up one at a time. 1, 2, 3, 4, 5, 6, 7, 8. There's the number in the middle. So that's the second quartile. And it's also the median. Now, we look to find the first quartile. Starting from here and here, we cover up one at a time. 1, 2, 3, and we end up at 2 values. So we look in the middle. Q1 is in the middle, so to find Q1, we add them and divide by 2. Q1 would be 8125. And we do the same at the top. 1, 2, 3, and we're in between numbers again. Right there, Q3, so that's 10.75 plus 11.25 over 2, put brackets around the numbers on top to make sure we get it right, and we end up with $11. So there's Q1, Q2, Q3. Damien's pay is in the 85th percentile for the group. What does the percentile mean? What is Damien's hourly pay rate? Well, what does it mean? Well, it means Damien makes more than 85% of people in this group. And to find out who he is, we take that 85% as a decimal, and we multiply it by how many people there are, 17. That gives us 14.45. Therefore, Damien is the 15th person. If there's 17 people, that's 17, that's 16, there's 15. That's his hourly pay. Therefore, $11.50 per hour. All right, one last page. A little bit to talk about data reliability, and then we're going to interpret some poll results, and then that's it for the first lesson. It's a long one. Data reliability. So let's decide which data source is more likely to provide reliable data for a research topic. If we were researching the benefits or adverse effects of drinking milk, would we want to use a data source that's a pamphlet from animal rights group that opposes dairy farming, or would we want to use the Canadian Food Guide produced by Health Canada? We would absolutely want to use the Food Guide. It would supply unbiased data, whereas this pamphlet for animal rights opposing dairy farmers would probably be anti-farming, animal rights, pro-animal rights, not anti-animal rights. Effects of logging on a population of bird species, a pamphlet from a wildlife organization or a forestry company advertisement. We're not going to use either of those, so there's actually no right answer to this one. Both those data sources would suck. C, possible complications of a flu shot. Should we use the Ministry of Health website or a website run by a group that opposes immunizations? Probably not the biased immunization opposers. We'd want to use the Ministry of Health website for unbiased information, where they go over the risks and benefits of getting a flu shot. A little summary. Animal rights group is promoting a particular point of view and may not be objective. The Food Guide was developed in consultation with thousands of other individuals, dietitians, scientists, etc. from across Canada. It will represent a more fair view. Both wildlife organizations and forestry company are promoting a particular point of view. It would be best to look for additional sources. Using a biased source is not terrible. You're getting one side of the story. Just make sure you get the other side of the story. While the Ministry of oh boy, how come I can't read? While the Ministry of Health website promotes the use of immunizations, it also describes possible complications. A group opposing immunizations is more likely to present only one side of the issue. All right, and last, let's interpret a poll result. The results of a poll conducted by ECOS in 2005 are shown. Poll says Canada should increase its humanitarian aid to poor countries, even if it means less spending in other important areas. And then the question probably was, do you disagree, neither agree nor disagree, or agree with that statement? And it looks like there's 1 to 3, 4, 5 to 7, so it looks like a sliding scale. On a scale of 1 to 7, where would you fall on that spectrum? So they grouped the top 3 responses as agree, the bottom 3 is disagree. So it's probably something like very much agree, agree, somewhat agree, neither, somewhat disagree, disagree, or very much disagree. Something like that were the options. So the question probably was, do you agree or disagree? With that statement on a scale. Scale with 7 options. How did the favorable responses compare in January and August? So here we go, August and January. So in August, we had 43% of people agreed, versus 31% in January. A line below the graph states the results are valid within a margin of error plus or minus 2.5 percentage points 19 times out of 20. What does this mean? Well, you see this a lot on survey results. It means if the survey was repeated. Uh, 95% of the time, we repeat the survey, you would get similar results plus or minus 2.5%. So that means any of these could be 2.5% higher or lower. So if you're taking 2.5% from this one, it's obviously going here or here. There's just a little bit of play there. So it's called a confidence interval. They're confident that 95% of the times we do this, we're getting similar results. Okay, a lot in that lesson. This should be the longest lesson of the unit, but thanks for watching, and I'll see you in the next lesson.